7.7b, we're still talking about natural logs. And again, when we think about logarithms, we're thinking about exponents. But a natural log is that special log. It's a log base e. And so e is that Euler's number. It was 2.718 or something like that. When we think about a natural log ln, that's the same thing as log base e. So we're more comfortable with log base 10 or log base 7 or log base any other number, but e is a number. It's 2.7 something something something. All right, so this is just a natural log, and we're going to put together a lot of the different concepts that we've talked about with logarithms. The first problem says expand each logarithm, and this is the one where we said with logarithms and with exponents, division is related to subtraction. All right, division goes with subtraction. So we can expand this, make bigger, and it's going to look like natural log u to the fourth minus natural log v to the fourth. And you might remember, oh yeah, we did this problem before with other kind of logs. This exponent, we're going to pull that around to the front. And so my final answer, 4 natural log of u minus 4 natural log of v. Expand. So then in a similar type problem, if I expand, you've got to remember that multiplication goes with addition. And I'm not trying to say that multiplication is the same thing as addition. It's just that when we expand this, that something about the properties, it's going to change my multiplication into addition. And if you want to think about why that is, go back and think about exponents. If I said x squared times x to the third, you're not really multiplying, you are going to be adding, because x squared looks like this and x to the third looks like this. So really you're just adding those two numbers to find that there are 5 of them, x to the fifth. So that's kind of a reason why what's going to happen is going to happen. So when we expand this, I'm going to see natural log of 2 plus natural log of 11 plus natural log of 5 squared. Only other thing we would need to do, and if you're able to skip this step and bring this 2 in front in one step, I'm fine with that. All right. But that exponent 2 needs to go in the front there. So natural log of 2 plus natural log of 11 plus natural log, whoops, 2 natural log, thank you, 2 times natural log of 5. That's expanded. So then here's another one. This is the exact same problem, only instead of numbers, you have variables. You're going to change these into pluses, and you're going to pull that 5 in the front, and you're going to see natural log of x plus natural log of y plus, what's the last one going to be? Five natural log of z. Very good. Now, expanding is not very useful. We need to know the properties, though, because when we get into the next type of problems, condensing is how we're going to end up solving equations. So we really need to know those properties so we can condense, so we can solve. And so now we're going the other way, condense. And I know that this subtraction is going to change into division. And so I can say 3 natural log of x divided by, that's not what I want. No, sorry. I also know that, let's go ahead and knock this out. This 3 is going to be an exponent, right? All right, so this 12 is going to be an exponent. So I'm going to have a single natural log, and I'm going to have a division problem. But on the top is going to be that x to the third, because that 3 in the front is an exponent. And on the bottom, I'm going to have y to the 12th. That's it. Condense. When they say condense, they mean make it smaller. Specifically, they only want to see one logarithm, one log. And so then problem 9 is the exact same problem, right? This 2 is going to be an exponent. This 4 is going to be an exponent. And we're changing the minus into division. I know that's not technically mathematically correct. I mean, we're not changing subtraction into division, but that's how these properties work. So there's going to be a natural log, and there's going to be 12 with an exponent 2 divided by 11 with an exponent of 4. And I kind of like to have parentheses there. Kind of tells me, it hints at the order of the operations in the problem. All right, now this is the exact same problem. I want to change it, so I hope you haven't worked ahead. I want to change it. We haven't done any that are plus, so I don't like it when all of them are the same. Let's change this to a plus. I just want to show you what happens when it's a plus sign, because multiplication or addition's going to change into multiplication. So it's very similar. Make sure you change that to plus, though. If you don't change to plus, you're going to be super confused. This 5 is going to be an exponent, so I'll see u to the 5th. And this 25 is going to be an exponent, so I'm going to see v to the 25th. But it's times, right? Natural log of u to the 5th times v to the 25th. Of course, if that was still subtraction, then it would have been a divide. Now we get to the main event. Solving equations. That's what we're trying to do most of the time in algebra class. We're trying to solve. But you have to know those properties in order to solve. We want to isolate the variable, but the first thing you're going to have to do is get those logs together. You're going to have to condense the logs so you only have one log. And so we use the same kind of property. I know that, bless you, I know that this subtraction is going to change into division. I can condense this into a single logarithm. Natural log of x over 5 equals 4. Now, in order to isolate, you're going to have to eventually get rid of that divide by 5 with the times 5. But before we can get there, we have to get rid of that natural log. Now remember, a natural log is a log base e, right? And so if I want to get out of a natural log, does anybody know what I'm going to do? What about e? Yeah, we're going to do a base e on both sides. And it looks super confusing on the left side, but the nice thing is that just cancels out. I'm going to have x over 5 equal to whatever e to the 4th power is, and that's why I want my calculator. E to the 4th power, 54 point, what does it say to round the thing to? 10,000, that's how many decimals? I think that's 4 decimal places, so 5982. 54.5982. All right, we are solving, so that means we need to isolate the variable. We're going to multiply by 5. Now check it out. If you've got that number in your calculator, I'm not going to retype the number. I've already got it in there. So all I'm going to do is hit times 5, and it's going to pull that whole thing down without the rounding. All right, and that's kind of nice because you don't really ever want to round until the very end. You don't want to round off a rounded off answer. So what is that? 9908. X is about 272.9908. Let me try something here. All right. Okay. Need to condense the logs. So we know that the plus is going to change into times, right? So natural log of x times 9. I might just switch that around. It's times, right? It's multiplication. X times 9, 9 times x, 9x, whatever. Same thing, like that. It's really the same type of deal. We've got to get rid of that log. So we're going to do a base e on both sides. 9x is going to equal whatever e to the 5th power is. 148.4132. 148.4132. But last thing I need to do, I'm going to ISO, so I'm going to divide by 9. And again, I've already got that on my screen. So just hit divide by 9, and it's going to take that number and pull it down. So 148.41, blah, 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 divided by 9, 16.4904. Really the same thing. Condense. Base E. To cancel, 4x equals e to the 4th. We already did that. Was 54.5982. And I'm going to divide by 4. So actually, can I copy that? Anyway, divide by 4. Get about 13.6496. I don't love the fact that we used a rounded off number and rounded off a rounded off number. It's going to be pretty close. Do you have to round off what? At the end? Well, you're saying you want to say 64955? Yeah, that's fine. But the directions say round up to 4. So that's why I did what I did. All right, last one. Looks a lot more complicated, but just work through your properties. We're going to condense the two logs because we know minus is going to change to division. So we can say natural log of that first thing divided by that second thing equals 2. And so it seems like we've got a lot more going on. We just have one extra operation that we didn't have before. We still have to get rid of our log. So natural log is log base e. Take a base e on both sides. So e to the 2nd power is that. I've got x minus 10 over 9 is about 7.3891 or so. Like that equals. Now, if I'm going to solve this, what do I do? There you go. Multiply both sides by 9 to cancel that out. X minus, 10 is about, and I take that number, it's on my screen, times 9, answer times 9, 66.5015. Last step, what do I do? Add 10, right? We're just trying to solve. We still do the same things we always do. So x is about 76.5015.